It's a pleasure meeting you all with another video. In this video, let's see the question from 1996 6th MCQ. We are not discussing the whole question. Why does the area of a hole expand during thermal expansion? This has to be the most common doubt among the students. Let us understand the fundamental of thermal expansion. Unless the molecular structure is at 0 Kelvin, the molecules will be under constant vibration. That depends upon the temperature. So 0 Kelvin is a theoretical value. We are not able to approach 0 Kelvin. Therefore, the molecules will be in a constant vibration. They will oscillate back and forth. What would happen if we increase the temperature? The amplitude of the vibration will increase. If the amplitude of vibration increase, what do you think would happen to the particles? They would slightly displace. As I have shown in the diagram, the particle slightly displaces to make room for vibration or for larger amplitude vibration. If each and molecule in the material starts displacing itself, making room for vibration, and expansion is observed. Since amplitude of oscillation depends upon the temperature difference, the thermal expansion delta L also depends upon temperature difference. We have the relationship that delta L is proportional to delta theta. Hope now you all have a better idea on why thermal expansion occurs. Let us apply this idea to see if the hole would expand inwards or would expand outwards only. Now if I increase the temperature of the system, a thermal expansion occurs. Let us see if there is a possibility for this hole to expand inwards. The white dotted lines be the portion after expansion. The square lamina has expanded and the hole has compressed. Let's see if compression is possible here. Why does thermal expansion occur? That is to make room for a greater amplitude. Now, if the hole shrinks instead of expanding, what do you think would happen to the molecules? The yellow color ring is the edge. Now I have drawn the expanded image of that portion only. So the yellow represents the edge before expansion and the white portion indicates its after expansion. If during thermal expansion, without expanding, if the hole shrinks, what do you think would happen to the molecules at this region? Are the molecules coming closer than they were, or are they making room for a greater amplitude? If you observe close, you will understand that during expansion, if the hole shrinks, the molecules are getting closer to each other. Instead, if they expand radially outward, if they make room for a greater amplitude, two adjacent particles here before expansion. After expansion, this should have been their positions. Before expansion, this was their spacing, and after expansion, this is their spacing. During thermal expansion, if the hole would have radially expanded inwards, then this would have been their separation. It is very clear, if the hole radially expand inwards, the molecules come closer. If and only if the area of the hole increases, molecules have a better spacing in between them. We know the purpose of thermal expansion, that is to create room for amplitude, that is fulfilled only when the area of the hole also expands. I hope you all would have a better idea on why the area of the hole also increases during a thermal expansion. If you are finding this video useful, share with your friends.